And discovering patterns in large data sets involving methods at the intersection of machine learning, statistics, and databases. I may have put that one in there. This definition is by the Association for Computing Machinery, Special Interest Group on Knowledge Discovery and Data Mining. So they are an authority, certainly. Here in this class, we're primarily going to be focusing on the machine learning and statistics part of this definition. We will be working with large data sets, and that's going to present its own computational challenges, but we're not going to be focusing on the design or management of these large database systems. And just kind of right off the bat, I want to start to give us a bit of a framework for what a data mining process looks like. So this is the cross-industry standard process for data mining. And I found it to be a very helpful way of thinking through the larger structure of what we're typically going to be doing when we work through a case in this class. We're going to start always by thinking about the context in which we're working. So instead of jumping right into the data, the first, and I would argue one of the most often overlooked and potentially critical steps of the data mining process is to identify clear project objectives. So to start the project knowing what you hope to get out of it. And knowing whether or not that's important. So this is something that like I said, is especially as we move into a world where data science consulting is becoming more and more common, is something that is surprisingly often missing. One of my previous students, he got back in touch with me saying that his firm, they helped manage large mining operations throughout the world, and this. They hired a data science consulting firm to help them optimize their mining operations. The data scientists got all their data, started looking through it, looking for patterns, doing this data mining operation, and came back to them with the suggestions that they stop running their trucks, their big, dump trucks, empty half the time. Now, I don't know if you know anything about mining operations, but typically there's a big hole in the ground, right? You drive a truck in, you get something out of the hole in the ground, you drive the truck out, right? You can't run that truck full all the time because half the time you're running the truck into the hole. So I mean, he was less than impressed with the results of this data science consulting firm. They did not move on to the next stage of the contract. And it ended up being kind of a waste of time for them. So this is something as I think, especially if you're in this program, you're likely very interested in the technical side of the process, and it's exciting to jump right into the data. If you miss on this, you missed on everything else. Yes, and could you put a name tag up? Sorry, I can't see it. Pat, there you go. Pat.
Yeah, so I had a question. I mean, it's kind of along the lines of what you just said about not understanding the business and saying, well, you need to run the truck full all the time. But
yep.
What I've noticed in enterprise asset management systems is that many times the people entering the data use the interface, like each person uses it differently, so the data is not clean at all, and the fact that they're using fields for not what they're meant for. So I was wondering if you're going to get into any of that about.
Yeah, well, actually, data understanding this is a perfect segue. Okay. Because once you understand the context is great. Understand, okay, this is a mining operation. The trucks are going to run half empty, empty half the time, because this is what happens in mining. Then you need to understand, what data you might have available to solve this problem, right? So part of that is going out and collecting the data. Part of it is just going out and physically figuring out, okay, what exists, what is out there, what database is it in, how can I pull it, how can I potentially merge it, the kind of like the nuts and bolts of bringing a data set together. But as part of that, you need to understand what generated it, to Pat's point. It turns out that, data isn't this platonic ideal that exists in a database that accurately represents the world. It was created by a process. That process is noisy. Now, and the noise in that process often has very specific implications for how you use that data. And we will see concrete examples of that as we go through the class, because it ends up being a first order consideration oftentimes when you're working with the data. Now, these arrows here, so it turns out that once you go out and you collect your data, you might have identified a really exciting objective, but once you go and look at your data, you might realize that you don't have the data you want to meet that objective. It just doesn't exist. It turns out that most data sets don't exist. And existence is one of the most important properties for data. So once you go out and figure out that's not the case, then you might have to go back and identify new project objectives. In some sense, short circuit this process, go right back to thinking about the context, thinking about other things you might be able to answer with the data that you have. Okay, so that's data understanding. Once you've understood your data, and feel free to interrupt me with questions at any point if anybody has any, we move on to the data preparation phase. This is, once we've understood what we've got, we know it's messy. We know that it's been generated by a particular process, and we've got to do something about it. So we're going to pick out features or variables that seem to be important for our process. Yes, Will.
Quick question. Are you going to make the slides that you have available on Collab?
So there will be, I actually have a series of videos for one of the classes that go through this again, so you'll have this. But I will make sure that I send these particular introductory slides to Valerie, and Valerie can help us put them on Collab.
Great, thank you.
Yeah. But you'll see this particular process again. So we will, you'll be picking out the features, the variables that you want. You will be potentially creating new features as combinations of the things that you have. You'll be doing things like filling in missing values and doing that with the view of how the data was generated and what those missing values might mean. And it turns out that if you ask working data scientists where they spend their time, the general consensus is that roughly 70% of the time for a particular data science process is here. This may seem like a step along the way to the exciting stuff, and it is a step along the way to the exciting stuff, but it's a big step. So this is something that we're going to spend a lot of time doing as well. Sifting through the data, trying to figure out what's meaningful, what's not, figuring out how we go about cleaning data, what a reasonable choice for cleaning data might look like, given what we know about the data set. So once we've done that, we can move on to, I think, what people generally think of as the meat of the data science process. Though again, as far as time spent, not the main portion of the working data scientist's time, which is modeling. So here's where we'll actually take the data, build typically some kind of mathematical model with it. Hopefully we'll find that it has some kind of predictive performance. We'll use particular metrics that can measure directly the performance of these models. And hopefully draw conclusions. Now, it turns out when you get to the modeling phase, you might build your model, do everything right to build the model, and realize that you don't actually have the data you need to predict what you're trying to predict, right? So we go back to the data preparation phase continuously in this modeling process, selecting new data, changing how we're cleaning the data, creating new features by combining existing data, and going back to this modeling process. Now, once we have a model that we believe is accurate and meaningful from a modeling sense, we move on to the evaluation sense, which might seem a little bit like a redundant step, given that we just talked about having metrics, that we were measuring the models and deciding that they were important based on this step. But it ends up being a distinct step in this process, because this evaluation step is not just, let's take synthetic metrics and figure out if our synthetic metrics are going up. It's more about evaluating the model within the context of the business and the project that you're looking at. You might end up with a statistically valid model that accurately predicts something, but is economically meaningless. Maybe you have variables in the model, data in the model, that you wouldn't actually have when you are trying to put the model into production. So you would take a step back, you'd evaluate it, and realize, okay, yeah, this model, assuming I had the data that I've got in my training set, would certainly be a good model, but maybe I won't have that data when I actually go to take this model into production. Or you might find that, yeah, you've got all the data, there's a statistically significant correlation between the features you put in and the output that you're looking at, but the actual predictive accuracy is so small, not that it's statistically insignificant, but it's small, that it's not economically meaningful. It doesn't actually affect operations in any meaningful way. And if that's the case, you might go back and to the modeling stuff, but often you'll go all the way back to the beginning here and kind of